Hello and welcome to an AP Physics C problem guide. This is problem number 22 of the Gauss's Law and Advanced Electrostatics unit. So in this problem, you have a charged plate of charge density sigma, and you also have a non-conducting small sphere of mass m and charge q at an angle theta in equilibrium from this positively charged plate. The question asks you to determine sigma. To start, we must first realize that t cosine theta, so the tension times the cosine of this angle, tension times the sine of this angle, minus Q times the electric field has to equal 0. Because if you remember, Q times the electric field, QE, is equal to FE, or the force, the electric force. Because KQ over R squared is equal to E, and if you multiply KQ over R squared by Q, you get KQQ over R squared, which is also FE. So the reason why we write this equation is so that we can relate the mechanics happening here and the electric components happening here. This is extremely influential in finding the surface charge density later. From here, we can say that t cosine theta has to equal t cosine theta minus mg has to equal 0. So that's saying that the weight of the ball has to be equal to the vertical part of the tensional force. That makes sense because it's in equilibrium, and this top equation makes sense because it's in horizontal equilibrium. So these two equations are basically saying that the sum of the forces on the ball are equivalent to 0. From here, we can state that QE, so the force on the particle, has to be equal to mg tangent of theta. So you can get that by combining these two equations. Moving some stuff around, we get E equals mg tan theta over Q. Now we have to substitute in values and plug them in on our calculator. So, substituting in values here, let me go back to the problem. We get M is equal to 1 milligram, or 0.000001 kilograms. Additionally, we get the charge Q equal to 2 times 10 to the negative 8 coulombs. From here, we can enter in all the values, and since the angle makes a 30 degree with the vertical, we know that the tangent of 30 degrees is some specified value. So let's just plug in all these. So we get 0.000001 times 2 times 10 to the negative 8th times the tangent of 30 degrees over, oh, just kidding, this 2 times 10 to the negative 8th must be on bottom because it is the charge. The reason that I thought it was on top is because it looks a lot like a Q up here. So I'm sorry about that. This is a G, so we just put in 9.8, or the acceleration due to gravity. Now, if we run this calculation, we should get E. And I will type it into my calculator now. 0.000001 times 9.8 times the tangent of 30 degrees gotta find my degree symbol in here. All divided by 2 times 10 to the negative 8th. Remember to put that in parentheses, otherwise it'll come out wrong. And we get the electric field is equal to 282.902. Now we can use the electric field to find sigma. So the electric field should be equal to sigma over 2 epsilon naught. So sigma should be equal to 2 epsilon naught E. Once we run this calculation out, we should get 2 times 282.902 times epsilon naught is equal to sigma. Epsilon naught can be found on your blue equation sheet right somewhere. 8.85 times 10 to the negative 12th. Putting that back into your calculator, 8.85 times 10 to the negative 12th times 2 times 282.902 gets you sigma is equal to 5.007 times 10 to the negative 9th. And if we check that with the original answer key, it can be seen that 5 times 10 to the negative 9th is the original answer. And if you're wondering, the units are coulombs per meter squared.